Mass energy relations. In this video, we are going to derive the mass energy relations of Einstein equations. We know that the force is defined as the rate of change of momentum. In terms of mathematical, we know that F is equal to derivative of momentum. And we know that every moving body has its own kinetic energy. So kinetic energy of a moving body is equal to the work done by the force that impart on the velocity of the body from rest. So from rest we take the integral 0 to v. V is the final velocity, and f dot ds is the force work done by the particle. So in terms of kinetic energy, we will get 0 to v into derivative of mass into v into ds, and we take the partial derivative. We will get derivative of momentum into ds by dt into dt, and finally we will get 0 to v into derivative of momentum. So this v came from the last equation, ds by dt. ds by dt displacement divided by time equal to velocity. So we will get v over here, and by cancelling each time we will get in 0 to v into derivative of momentum. So according to relativity equation, m0 is the rest mass and m is the moving particle mass. So this is a relativity equation of a moving particle mass. So we are putting this m in the previous equation, 0 to v into mv. We are putting the m, replacing m with the relativity equation of m. So we will get 0 to v into m0 by v into 1 minus v square by c square. And taking the integration and solving the equation, we will get the final. I'm going to final result. I'm not going to describe all the mathematical step in this step, but you can understand from the board. This is very clear from this board, so I'm not going to all the depth of the integration. And we are going to final step. We will get mc's. I will show the each and every step. This is the last step, second steps, and third step. Okay. In this final equation, we will get mc square into 1 minus v square by c square minus 1. This is the second last step of the equation. So we are going to multiply the mc square over the bracket. Finally, we will get m0 by 1 minus v square by c square minus m0. This m0 by 1 minus v square by c square is the relativistic mass equation. So we will put m minus m0 into c square. M minus mc0 is the mass defect. So finally we will get change in mass or delta mc square. So delta m came from the m minus m0. This is a mass defect or change in mass, mc square. So this is a Einstein relativity equation of E equal to mc square. Thank you.